All right, we're going to start our next section of notes, density in the metric system. So make sure on the top of your page you add this title, density in the metric system, so it's easier to find this information in the future. And you start on whichever page you have available next within your science notebook. Before we get into our notes, it's important for us to make sure that we are identifying our purpose for the day. And there's three things we want to make sure we're focusing on. Number one, we want to know the SI unit for measuring density. So we want to make sure we're on the lookout for what is that official unit we use for density. Number two, we want to know how to find a density through calculations. So we'll talk about how we find those numbers and then what we do with numbers and calculating to actually find our density. And number three, we want to know if an object will float, sink, or suspend in a liquid. And so we'll talk about that. So those are the three things we want to make sure we're on the lookout for, and we want to make sure we understand before we end our notes here today. So starting off here with our metric units, our density refers to the amount of matter in an object contained in a given volume. Okay, so basically what that's telling us is the amount of stuff in a given amount of space. The base unit of density in the metric system is the gram per meter cubed. All right, you notice those are the base units for the matter and volume, so we just combine those. However, the SI is kilograms per meter cubed. All right, so the only thing that changes, we actually change grams into kilograms, and we talked about the same reason before, is grams is a pretty small amount, so we usually use kilograms because it's a more appropriate measurement for those types of dimensions. So now our density combines both mass and volume into one measurement. And so that's the really big idea, is density just takes these two ideas and puts them together. We measure them in the exact same way. So we find mass using a triple beam balance or maybe a digital scale, and we measure the volume using a graduated cylinder, using water displacement method, or length times width times height. So those still are found the exact same way. We just need to find both of them in order to ultimately find the density. The density of water is 1 gram per centimeter cubed. All right, so that's the known density of just regular water. Objects that are above this will sink. So if they are higher than it, they sink. And objects that are below this will float. And objects very close to this number will suspend. So when I say very close, I'm talking a number range of probably about maybe 0.9 to maybe 1.1 grams per centimeter cubed. And again, so we're talking very close numbers again, and then those will suspend. So it's really, really similar. A good example of this would be, well, we'll look at a few, but like ice would be a really good example of something that would suspend, in which you know that it kind of floats on the water, but at the same time, a lot of it's below the actual water. There's a little bit that actually sits above the surface. So we'll look at that more later, actually, in these notes. And one other final piece to kind of emphasize here is looking up in this top right corner with our density, we have kind of, okay, let's label these. So if we have, you know, cube A and we have cube B, all right, so kind of look at it. Which one do you think is more dense? Okay, so now if we look at our definition of density, density is the amount of matter. All right, the amount of matter that we have. Oh, why does it keep writing? The amount of matter and the amount of volume. So in this scenario, our volume is kept the exact same. The only thing changing is these green spheres we have in here, and those are going to be really the stuff. That's the matter. And so if we notice, there's a lot more in object B than it is object A, so we should see that object B has a far greater density. All right, so how are we actually measuring our density? Well, we find density by first finding the mass and by finding the volume of our objects. So we find the mass, find the volume, and we do that in the exact same way that we always have it, all right? Again, we use triple beam balance for mass, and we use one of the three methods that we have for finding volume of the object. We then divide the mass by the volume to find the object's density, all right? So density is going to be equal to mass divided by volume. And so I got our fun little, if you're a Star Wars fan, mass divided by volume, it is your density. And so that's how we're going to find the density of an object. Again, the amount of stuff per amount of space, the volume. All right? So if that's the case, let's go through a few practice problems here to make sure we're kind of getting the idea. So our example number 1, I find the mass of a rock to be 10 grams. So let's make sure we get that information. Let's highlight that important information. So we have the rock is 10 grams. If the rock has a volume of 5 centimeters cubed, what is the density of the rock? So if we find this amount, so we got to know that, okay, so our density, we currently don't know. Okay, the mass is 10 grams, and the volume is 5 centimeters cubed. So if we know that our density equals mass divided by volume, then that means our density is going to equal 10 grams divided by 5 centimeters cubed. So if we actually do that calculation, then we're going to end up with 2 grams per centimeter cubed, right? Because 10 divided by 5 is 2. So what this is telling us is that for every cubic centimeter, there's 2 grams of stuff in this rock. And so if we had even more space for it would follow that same trend, and we'd have more mass. If we took the volume down, then we'd have less mass, and that means, but our density stays the same in all of these scenarios. So let's look at another example. Now in this scenario, we have something else. So we're trying to find something else in this scenario. So when we're looking at this, we have, so I know the density of the metal cube is 8 grams per centimeter cubed. The volume of the cube is 4 cubic centimeters. What is the mass of the metal cube? So that's what we're trying to find. We're actually trying to find the mass. Okay, so that's what we got to pay attention to. So again, if we write out our information, so we know our density is actually 8 grams per centimeter cubed, and we know that the volume of our cube is 4 centimeters cubed. What we want to find is, well, what is our mass? Right? We don't know that. We want to know that. So this one, you don't have that equation already solved for you, so I'm going to kind of help you out on this one. Now, we said that density is the amount of stuff we have in a given amount of space. Okay? Now, we know that we have 4 cubic centimeters of space. And so you can think of density as a ratio, in which that I have 8 grams of stuff for every cubic centimeter. So that means I have 4 cubic centimeters. All right? So that means it's really going to be, so one way you could think about it is if I have 8 4 times, because if I have for every cubic centimeter, so if I have, let's just say that's a cubic centimeter, that's a cubic centimeter, cubic centimeter, cubic centimeter, then for each one of these, I'm going to have 8, 8, 8, and 8 for my density, right? So I'll have 8 grams of stuff. Right? So now if we have just that one cube, all right, so now if we just have one big cube, okay, and so now this is going to be the same thing as if I have those 4 sections in there, in which each one of these is 8, 8, 8, and 8. And then if we actually do that, that's going to basically be the same as doing 8 times 4, right? So that's going to give us 32 grams. Okay, and so that's where we're going to get that. So the actual calculation then is mass equals our density times our volume, which is going to then equal 8 times 4, which equals 32 grams. All right, so how does knowing density actually help us? One way that it can help us is by knowing if something is going to float or sink in water. So looking at this, knowing the density of a substance or object can be useful information. If we know the density of a substance, we can predict if an object will float in water. Look at the table, or look at the below table. Which substances do you think will float, sink, and suspend in water? Water has a density of 1 gram per milliliter. So looking at this information in our table, we can see that we have air, ice, aluminum, gold, and something called osmium. All right, so air, it's something that has mass, all right, and so it's going to have a standard density as well because it also has a form of volume. So we can have a density for air, and so that's going to be 0.01 grams per milliliter. All right, so looking at that, we can identify that air is going to float, all right? So let's pick a color here. I'm going to highlight anything that's going to float in blue. So let's go ahead and highlight this. That's going to be floating. Okay, now this makes sense, right? Think about a lake or a pond or a pool in which the air stays above the water and the water is below it, right? I mean, it may be kind of weird to think about it that way, but that's why water goes to the bottom of your glass when you fill it. There's air in the glass, but when you put in the water, it goes to the bottom and pushes the air out. Okay, moving on with ice. So now ice, if we look, we see that it has a density of 0.9 grams per milliliter. Now that's really close to 1. And if you remember, if I said anything is really close to 1, then it's going to do something called suspend, or kind of float in the middle of the water or barely at the surface. And so in this case, I would say that ice is actually going to be something that's going to suspend. So I'll just kind of highlight this in kind of a gray-black to signify that's going to suspend. It's not really a one way or another. Okay, now looking at the rest of these, we see that we have 2.7, 19.3, and 22.59 grams per milliliter. These are all well above 1 gram per milliliter, which is what our density of water is, which means if it's greater than 1, especially by a large amount, it's going to sink. So then let's, I'm just going to highlight these in red, saying, okay, well, these are going to sink. Okay. So again, just to kind of, make sure we see this, is we have this is going to be sink. And then this is going to be suspend. And then we're going to have float. All right, and that's just based on the density of the materials. And now that wraps up our notes for density. Now we're going to make sure that we go through these 3 questions, guiding our summary. Do not forget to write your summary at the end of your notes. Remember, write your summary and then box it in at the very, very end. Your summary should talk about, okay, what's the SI unit for density? How do we find density with calculations? And how do we determine whether something is going to float, sink, or suspend in a liquid? And that ends our notes for density. If you have any questions, please let me know in class. Thanks for watching.